so 7.4 is talking about equations in quadratic form that are not, God bless you, actually quadratic equations, but they look like they are. They really look like they are, and we can treat them like that. So let's go ahead and take a look at what I'm talking about. Please look at these three. Look at all three of them. Study the similarities. Why are they all very similar in nature? Explain, please. Explain why they're all very similar. Annette?
The C values are all the same, and the coefficients of B and A are equal to each other.
Yeah, so for all of them, A is, B is, C is, go ahead.
So A is X.
It's the number in front.
3. No,
B is 3, agreed. C is?
C is 2X, 2 over X.
Look at the original. Just go here.
That.
A, B, and C, what are they?
A, B, and C. L1 and then -10.
Hey.
So I thought you meant the similarities.
That's all right. Yeah, so carrying them down, you see that they're similar. But for all of them, A, B, and C are 1, 3, and -10. Even the third one, look. There's a 1 here, there's a 3 here, and a -10 here. So what's changing in each of these?
The term for the variable is
Exactly. The variable position is now taken on by an expression. In the second case, 2x plus 4 is really taking the place of x. And in the third case, 2 over x is taking the place of x. Does that make sense, what I'm saying right now? We all clear on this?
Yeah.
So what we can do here is we can take a look at this and say to ourselves, well, you know what? We could set these equal to something like called u, or give them another value for them. So let's take a look at an example of what we're talking about. So here's our first example. Do you want to multiply all of this out? George, do you want to multiply out 2x plus 1 times 2x plus 1 and distribute? It's a lot of work, right? So instead, look at the problem and say to yourself, give me another variable besides x. It doesn't matter, any variable. U. Did you use u for any reason besides just to use u? Good. We used u in the past. Very good. We used it earlier when we substituted in. So let's let u equal 2x plus 1. So as a result, what does that make this equation? Tristan, wherever you see a 2x plus 1, replace it with u in the equation. What do you get?
Minus 4u equals 21. Or you can just put the minus 20.
Yeah, same difference. Does that make sense? Right? Isn't that so much easier to solve? Look at it. Move the 21 over. Factor. I know, we forget about factoring, by the way, at this point. It happens all the time. Because I do so much with the quadratic formula and completing the square, students forget that sometimes you can just factor. What do you got? What do you got, Bridge?
Minus 7.
So u equals 7, and u equals -3. All right, I'm done. Let's move on to the next question. Obviously, I'm not done, right? I'm joking or leading with that confidence. Why am I not done? What's the goal for this problem? Annette?
I'm trying to find the value of X.
You're trying to solve the original function, which was a function of x. Very good. Or equation, which is an equation based on x. Well, if u is equal to 7 or -3, take the let statement from earlier and set that statement equal to either 7 or -3. So take whatever the definition of u is and set it equal to the value that u became. So again, set this equal to that, and set this equal to that. What do you got?
X equals 3 and x equals -2.
3 and -2. I'm going to subtract 1, that gives me a 3. I'm going to divide by 2. Subtract 1, that gives me a -2 when I divide by 2. So my solution to a problem like this, although seemingly lengthy at first, becomes rather short when you use a substitution to make it a little bit simpler. That makes sense? That's why this topic, the name of this topic specifically, is called equations in quadratic form. They look like quadratics, but you might have to do a little bit of work first, right? Might have to do a little bit of work first. All right. Some of these other ones are a little trickier. Let's see how we do on these now. How about this one? This one's really kind of. What do you think?
I think maybe you make.
You both had your hands up, and I looked at both of you guys.
Well, I
Okay. So since it's the square root for x, then you can just count x as x squared, right?
Count x as x squared.
Yeah, and then like if you multiply the whole thing by x, I don't know.
You're on the right track. He's on the right track. See what he's seeing? He's like, you know, this is like the x squared. This is like the x, really, right? So if you're confused, write this equation out with u wherever you see something else and u squared. What would it look like? It would look like this. It would say 2u squared minus 7u plus 6 equals 0, right? That's what it would look like if I wrote it as a proper quadratic. Well, that tells me that u is really taking the place of root x. Sorry, I ruined that for you. Sorry. And I can see that because of this right here and right here. So let u equal root x to start. That's your let statement. So when in doubt, look at the middle term to see what u is equal to. Is that clear? Look at the middle term to help you. We might have to change that statement a little bit in a minute, actually. Or we're going to have to manipulate it, but I'll explain when that is. But for the most case, look at the middle term to figure out what u is going to be equal to. And now the equation can be solved pretty easily. I think it's factorable with 3 and 2, right? Minus 3 and minus 2?
No, minus 6 and minus 1.
Oh, actually, yeah, that works better.
Come on, check each other, guys. When I multiply that out, I'm going to get a positive 4. I'm going to get a negative 4. I'm going to get a negative 4 and a negative 3, which will give me a negative 7. This looks right. Right? Because look, the inner term will give me negative 3. The outer term will give me negative 4, yielding negative 7. 3 times 2 is 6. They're both negatives, yielding a positive. This looks good. Now what do we have to do? Solve for u, but that's not the end step. So in this case, u is going to become 3 halves, and here it's going to become 2. If I want to solve for x, though, I have to remember that if u is equal to 3 halves, or 2, I can replace that right here, or replace that right here. So really, 3 halves is equal to the radical x, and 2 is equal to radical x. So x is 9/4, and x is 4. X is 9/4, and x is 4. First two rather straightforward. Questions. It is a C day, so we're probably not going to make it to the next 3 examples, but I do want to press on because they're a little trickier. The next one, what do you think? What do you think with this one? Take a look, please. What do you think you should do? You can't take my advice from the last problem. It's not going to help you here. George, what do you think?
You can make it 3 over x equals u.
Why would you do that, George, in this problem, George?
Because 6 over x is just 2u, and 3 over x is
This is really just double 3 over x, isn't it? And I see that 3 over x is squared, so I want to make this equation u squared, don't I? Well, that means let's let 3 over x equal u in this case. But what does that mean? That means that we have to break this into 2 times 3 over x. See what I'm doing? Look, what's 2 times 3 over x? That's just 6 over x. So the 2 carries down as a coefficient, and 3 over x becomes a u again there. Minus 35 equals 0. Very good, George. Okay, so this is one of the problems where you're not going to take the middle term and let it equal u right away. We have to manipulate the middle term here and make it similar to the first term so that we could do this. Unfortunately, well, actually, no, fortunately, not unfortunately. For this one, we're going to get two answers. They're both going to work, yeah. We're going to get u plus 7, u minus 5. So u equals negative 7, and u equals 5. Now, remember that these values are going to go in for u up here. So negative 7 equals 3 over x, and 5 equals 3 over x. What's the fastest way to solve these? You guys should all be good at this point in your life, but just to reiterate this, because I know this comes up in my junior classes. The fastest way to solve something when it's in a denominator is a variable. The fastest way to solve it. How would you solve it? What's any way to solve it? Annette?
Multiply by x.
Multiply by x and then divide by?
Negative 7.
Yeah, so just, what are you doing inherently?
You switch.
Switch the x to the negative 7. Okay? I mean, at this point in your life, you should know that, yeah, you can multiply by x and then divide by negative 7. Oh, there's your answer, negative 3/7. Or honestly, just switch these two. So here, this would just be 3/5. And again, yes, multiply by x, divide by 7, but make it quicker on yourself. Whenever you have a number equal to a fraction, and you're trying to get the denominator by itself, just switch these two. Even if this were a huge expression like 2x squared plus 5, you could switch 2x squared plus 5 with negative 7 by multiplying and then dividing. Not bad. This one here looks a little bit tricky, but it's not that bad, and you really don't even have to use u for this one if you don't want to. I'm going to start by doing this first. Now, you could factor this already because we did this earlier in the year. You guys are a bit advanced and you're good at your math this year. So I already talked about a problem like this. Anybody know what it would factor into without using the u part? What would this factor into?
X squared plus 4 and x squared minus 3.
Yeah, x squared plus 4 and x squared minus 3. And you guys know that because the only way to get x to the fourth is by making your coefficients x squared and x squared. So that's one way to do it for sure. You could also do it with the old method. Let u equal x squared, making this equation u squared plus u minus 12 equals 0. But again, you're still going to yield the same factors. Okay, it's going to be u plus 4, and again, u minus 3. So u is going to equal negative 4, and u is going to equal positive 3. Since those are equivalent to this up here, since negative 4 and 3 are the values of u, they're equivalent to x squared. So what are your answers going to look like here? What are your answers going to look like? You're going to get negative 4 equals x squared, really. And you're going to get 3 equals x squared. What are they going to be?
For the first one, it would be 2i. And
Plus or minus 2i.
2i. And for the next one, it would be root 3 equals x. Plus or minus root 3.
How many answers did we get? How many answers? 4, because it was what? X to the 4th. See what I'm doing there? Okay, the highest degree, or the degree of the polynomial, represents the number of roots that you will indeed get. All right, we're on the last one, so we did pretty well with this, guys. You guys are very good. So the last one here, this is probably the trickiest, because it doesn't look like anything's going to work, right? Honestly, it looks like nothing's going to work. Here's the concern, here's the issue. The 3 out in front is fine. Since 2x minus 3 is squared, I know already that that's going to be u. 2x minus 3 has got to be u. Okay, so this is going to become 3 times u squared. We know that already. But that middle term is messed up. 10x doesn't work, right? But if I look at this is 2x, isn't it? What do I have to take out of 10 to get to 2? What do I take out of the 10 to get to 2? What do I factor out of 10 to get to 2?
5.
A 5, right? Well, that means that I need to factor 5 out of this also and get to this. But that doesn't work, does it? So break 19 up into something that when you take a 5 out of it gives you 3. What, when you divide by 5, gives you 3? 15. So write this as this. Because negative 19 is really negative 15 and negative 4. And then what you can do is look at this by itself, factor 5 out, and it becomes okay, it's a messy problem because it's not obvious at all. The let statement of letting u equal 2x minus 3 was the one thing that kind of alluded to the fact that we needed 2x minus 3 here. If I needed 2x minus 3, I got to take a 5 out of 10, so I got to take a 5 out of something to give me a 3. It's got to be 15. If I use 15 up here, I've got 4 left over to make it 19. This is messy. It doesn't factor. The quadratic formula will give me the following. For the sake of time, I'm just jotting it down, okay? Here's what the quadratic formula gives me. That's the value of u. Now, I can take that value, this is an exact value. I can take it and then try to find x by setting that equal, right, to equal 2x minus 3 up at the top up here. 2x minus 3 equals that whole thing. That's going to be messy, isn't it, to solve? So this is one of the times where you probably want to get approximations. Approximately, this is 0.59 or negative 2.26. That's a lot easier to work with, isn't it? Take those numbers now and set them equal to 2x minus 3. Again, take the decimal approximations of u. U is an exact value over 6 here. That's messy. I don't want to set, if I set this whole thing, look, set this thing right here. That's a mess. You have to solve with the plus or minus and radicals. It's not worth all that extra work. Go through just getting a decimal estimation here and solve for the x value with that same decimal. Let's see. I know you get 1.8 and 0.37. I forget which is which. Let's see. If I add that over, I'm going to get 3. 3 divided by 2. Yeah, it's going to be around near 1.8. So this will be x equals 1.8, approximately, and x equals approximately 0.37. Now, if you want to challenge yourself, honestly, go ahead and do it. Set the exact value from our answer here. Set the exact value equal to the 2x minus 3 instead of the estimation. Set the other exact value, or the other root, equal to 2x minus 3. And then you can just solve this. It's not that difficult to solve. I'm just saying it's a whole lot more work, right? Our two roots are plus or minus. Here's the plus. Here's the minus right here. So I can go ahead and set those equal, multiply everything by 6, move the number over, solve for x. You can get the exact values for both of these. So multiplying by 6, this is going to become 12x minus 18. Then I have to add the 18 over. Add the 18 to negative 5. And then divide by 12. Yeah, guys, definitely do the homework for tomorrow. Okay, those will be your two exact values. Have a good day, guys.